The observable universe is 93 billion light-years wide. The universe is about 14 billion years old, right? So how can the observable universe be 93 billion light-years wide? The answer lies in expanding space. As the universe grows and expands, distant galaxies move further away. So the light we see now was emitted when they were closer. They're much farther away today. It's like painting dots on a balloon and blowing it up. The distance grows even though the age doesn't. We're looking at ancient light from objects billions of light years beyond their starting point. The sun's core is a nuclear furnace. What's really going on inside the sun? Its core is a nuclear fusion reactor, crushing hydrogen atoms into helium under intense pressure and heat. About 15 million degrees Celsius. Every second, the sun converts 600 million tons of hydrogen into energy. That reaction releases photons, particles of light, which take thousands of years to reach the surface, and just 8 minutes to travel from the sun to Earth. So the sunlight hitting your face right now started its journey before the invention of writing. Black holes can evaporate over time. Black holes might seem eternal, but they actually evaporate. Stephen Hawking proposed that black holes emit tiny particles over time, with these radiation particles becoming known as Hawking radiation. This causes the black hole to lose mass, but very slowly. For big black holes, it takes longer than the age of the universe. But for tiny ones, they could disappear in a cosmic flash. Even the darkest objects in the universe can fade. Rogue planets wander the galaxy alone. Not all planets have a home. Some are known as rogue planets, massive worlds that don't orbit a star, meaning they're outside any galaxy. They drift freely through space, possibly after being ejected from their original solar systems. Although there are other possible ways planets could become rogue. Astronomers estimate there could be billions of these lonely wanderers in our galaxy alone. Maybe even more rogue planets than stars. Without a star, they're cold, dark, and hard to detect. But some may still have liquid water beneath thick surfaces and atmospheres of icy shells, kept warm by internal heat. These cosmic orphans challenge what we know about where planets can exist. The largest structure in the universe is the Hercules Corona Borealis Great Wall. The biggest thing known in the universe isn't just one galaxy. It's a supercluster of galaxies and matter called the Hercules Corona Borealis Great Wall. It stretches across 10 billion light-years, which is also the distance it is from our planet. It's so large it shouldn't exist based on our understanding of the universe's structure. It was discovered through patterns in gamma-ray bursts, which are often linked to massive cosmic events. Imagine something so big, it would take half the age of the universe to cross it. Now that's a wall. Your body would boil and freeze in space at the same time. Step into outer space without a suit, and you're in big trouble. Because there's no air pressure, the liquids in your body, like blood and saliva, would start to boil instantly. But at the same time, space is cold, around negative 270 degrees Celsius, just above absolute zero. So you'd also freeze, especially in areas without direct exposure to the sun. And you wouldn't explode, but you would pass out from lack of oxygen in 15 seconds, and die within 90. It's not dramatic like in the movies, but it is just as deadly. Astronauts grow taller in space. When astronauts go to space, something weird happens. They get taller. In spaces with low gravity, such as space, the spine decompresses and the vertebrae stretch apart. The result? Astronauts can grow up to 2 inches taller during their mission. But don't get too excited, it's temporary. Once they return to Earth's gravity, the spine recompresses, and the vertebrae move closer to each other together so astronauts shrink back down. Still, space lets you experience life with better posture. The Voyager probes are still communicating from interstellar space. Launched in 1977, Voyager 1 and 2 were designed to explore the edges of the solar system, but they just kept going. And now both are in interstellar space. Voyager 1 is now over 15.5 billion miles from Earth. Yet it still sends data back using a 20-watt transmitter, about the power of a refrigerator light bulb. It takes over 22 hours for its signal to reach us. They carry the golden record, a message to any alien life that might find them. Voyager is humanity's furthest whisper into the cosmos. Pluto has ice mountains and blue skies. Pluto may be small, but it's anything but boring. When NASA's New Horizons flew by Pluto in 2015, we discovered water ice mountains as tall as the Rockies, and vast frozen plains. But even more surprising, Pluto's thin atmosphere scatters sunlight, creating blue skies just like Earth. And beneath its icy crust, scientists think there could be a hidden ocean of liquid water, from just a rock to a potential home for life. Pluto's blow-up is real. Don't sleep on dwarf planets. The dark side of the moon isn't always dark. You've probably heard of the dark side of the moon. But here's the truth. There's no permanent dark side. The moon is always half lit by the sun, just like Earth. What people mean is the far side, the half we never see from Earth, because the moon is tidally locked, showing us the same face forever. But that far side gets sunlight just like the side we see when it's facing the sun. In fact, the term dark side is more poetic than scientific. The moon's not hiding any secrets in the shadows. It's just rotating in sync. Galaxies can collide. And we're next. Galaxies aren't static. They move through space and even collide. And our Milky Way is on a collision course with our neighbor, the Andromeda Galaxy. They're set to collide in about 4.5 billion years, merging into a single massive galaxy, sometimes called Milkdromeda. But don't worry. Stars and other matter are so far apart, the odds of any direct collisions are low. It'll be more like a cosmic dance than a crash. The night sky will change dramatically, though, with millions of new stars lighting it up. Subscribe if you want a front row seat to the galaxy's future.